Hey guys, Mr. Milton here. Today we're looking at operations with radicals notes. At the end of this video, you should be able to distribute with radicals and you should be able to FOIL with radicals. Okay, we kind of already talked about this, but I know that it looks a little bit different and we're adding a little bit of concepts together. So separate this out by itself just so we can make sure we're taking gradual steps up to learning all this information. Okay, because when we're talking about FOILing, remember that we're really just talking about multiplication. Like I said, we've already dealt with multiplication with radicals. Okay. And remember that when we're multiplying, we can put unlike terms together. Okay, the main thing to remember is that when multiplying, numbers inside the radical can only be multiplied with numbers inside the radical. Numbers outside the radical can only be multiplied with numbers outside the radical. And so that's why you might have heard me a million times this chapter say inside by inside, outside by outside. Okay, so got to make sure that we remember that as we see a lot of multiplication problems in a row. So let's look at this. It says distribute in each problem, make sure your answers are simplified. So we have 3 times 2, outside times outside, so we can do that 6, and 3 times -4 radical 5. Okay, 3 is on the outside. It will multiply with the 4 that's on the outside and not the 5 that's on the inside. So we have 6 minus 12 radical 5. As we're simplifying and making sure that we can do all the operations that we're asked to do, these are not like terms. So we'll just leave it as 6 minus 12 radical 5. Some people will say, hey, does the order matter here? Not as much as when we're talking about polynomials and writing it in standard form. So if you did, I wouldn't understand why you would want to change the order here. If you did, make sure that you remember that the sign in front of the term goes with it if you were to move it. Okay, so not recommending that you move it unnecessarily, but if you did move it, make sure that you remember the sign in front of your term goes with the term. Okay, number 2, radical 5 times 2 radical 2 plus radical 5. Again, we're distributing this and we're following the rule inside by inside, outside by outside. So I have 2, because radical 5 is on the inside, so we'll multiply that. Radical 5 times radical 2 is radical 10. And radical 5 times radical 5, that gives us radical 25. Okay, which will simplify. Radical 25 breaks down to 5 and 5. So we have a pair of 5. So 2 radical 10 plus 5. And that's our answer. Okay, they're not like terms, so we can't add them any further or simplify it any further. Number 3, we have 5 radical 6 times 8 minus 2 radical 5. So as we multiply, we distribute here. 5 times 8, because outside by outside gives us 40. Radical 6. 5 radical 6 times 2 radical 5, that gives us 5 times 2, because those are on the outside, 10. Radical 6 times radical 5, 30. Okay, as we try to simplify this, we can't simplify any further because 30 breaks down to 3 times 2 times 5, so no pairs. And 6 breaks down to 3 times 2, no pairs. So we just have 40 radical 6 minus 10 radical 30. Okay, again, the big emphasis here is making sure you don't multiply outside by outside, okay, and inside by inside. If you do that, you're going to be mostly there already. Then simplifying, which we've been working on the entire unit. So we have 3 radical 2 times 7 radical 2. Outside by outside, 3 times 7 is 21. Inside by inside, radical 2 times radical 2 is radical 4. Okay, I'll move on here. Outside by outside, 3 times 4 is 12. Inside by inside, radical 2 times radical 6 is radical 12. And now we simplify. Radical 4 is 2, square root of 4 is 2. So 21 times 2 is 42, right? Okay, radical 12 breaks down to 4 and 3, 2 and 2, 2 radical 3. So that gives us 12 times 2 radical 3. 12 times 2, 24 radical 3. It's still positive. So our answer then is 42 plus 24 radical 3, because we can't simplify it any further because they are not like terms. In the first 4 examples, we are multiplying a monomial into a binomial. We did that already in our last polynomials unit. What happens when we multiply a binomial into a binomial? Binomial into a binomial. Okay, and this is where FOIL comes in, or you can still use the box method if you choose to. Okay, either way, as you guys know from last chapter, I kind of like how the box method keeps my answers and my work restricted in one place, and I can find my like terms a little bit easier. But either way, FOILing and box method is the same operation, different way to organize that. So let's look at it. We have 2 plus radical, or 3 radical 5 times 4 minus 2 radical 5. Again, like I said, I don't really care which method you use. I'll use one FOILing. So 2 times 4 gives me 8 firsts. 2 times negative 2 radical 5 gives me minus 4 radical 5. Outsides. Okay, then I'll do radical 3 radical 5 times 4, which gives me 12 radical 5, positive 12 radical 5. And then 3 radical 5 times negative 2 radical 5. 3 times 2 is 6. Minus 6. Radical 5 times radical 5 gives me radical 25. Okay. At this step, I want to make sure that I'm simplifying things. Radical 5s don't simplify. Radical 25 goes into 5. So this becomes 6 times 5, or negative 30. Okay. So now as I'm looking at my like terms, and I'll write that up here. Okay, as I'm looking at my like terms, I'm going to put those together. 8 and negative 30, that gives me negative 22. Negative 4 radical 5 plus 12 radical 5 gives me positive 8 radical 5. Number 2. Okay, so one of my binomials, I have 7 minus radical 2. And then 4 minus 5 radical 2. In either way, box method or FOIL, I really don't care how you do it. 4 times 7 is 28. 4 times negative radical 2 is negative 4 radical 2. 7 times negative 5 radical 2 is negative 35 radical 2. Negative 5 radical 2 times negative radical 2. Negative times negative is positive, so that would be positive 5. Radical 4 is 2, so 5 times 2 is 10. Okay. And so now I go through and I add my like terms together. 28 plus 10, 38. Negative 35 radical 2 minus 4 radical 2 gives me negative 39 radical 2. Okay. Either way, I don't care which way you choose to do those operations. Okay. But I do want you to show your work and show me where you get your numbers from. All right. Number 3, we have radical 6 plus 5 radical 3 squared. Remember, when we square something, that means we're multiplying it by itself. So I would typically encourage you to rewrite this problem as a multiplying problem rather than a square problem. Same thing. Okay. So again, either way you do it, I don't really care. I'll do this one box method, another one FOIL. So as we look at it, we have radical 6, 5 radical 3 times radical 6, 5 radical 3. Okay, so radical 6 times radical 6 gives us radical 36, which is just 6. 5 radical 3 times radical 6 gives us 5 radical 18. 5 radical 18 here as well, right? And then we have 5 radical 3 times 5 radical 3. 5 times 5 gives us 25. Radical 3 times radical 3 gives us radical 9. Now I'm writing all of these small because I know I'm going to have to simplify these radicals, okay? Just like I had to do with radical 36. So when I look at 5 radical 18, that breaks down to 9 and 2, a pair of 3s. So it's 15 radical 2. Okay, and the nice thing is that it's the same both places. Radical 9 is 3. So 25 times 3 gives me 75. So now as I go through and I choose out my like terms. 6 and 75 gives me 81. Radical 15 radical 2 and 15 radical 2 gives me 30 radical 2. Okay. Then number 4, we have 4 plus radical 10 times 4 minus radical 10. You might be like, wait a second, this kind of rings bells. Hopefully it does. Let's look at it. Firsts, 4 times 4, 16. Outsides, 4 times negative 4, or negative 10. Negative radical 10, negative 4 radical 10. There we go. Insides, radical 10 times 4 is positive 4 radical 10. Lasts, and that will give us negative, because we have a positive times a negative, radical 100. Okay, radical 100, though, is 10. You'll notice when we multiply a radical by itself, it disappears, right? We talked about that with rationalizing our denominator. Okay, so now as we go and add our like terms together, we have negative 4 radical 10, positive 4 radical 10. They cancel out. So we're left with 16 minus 10, and our answer is 6. It's kind of cool that we multiplied two things and got two things that had radicals in it and just got a number, okay? So let's look at this really quickly. It's kind of additional, like I want to show you this so you know it, but not necessarily, this won't necessarily be something that you're going to be tested over, even though you might see some practice problems like this just a couple times just to help your Algebra 2 teacher out. All right, so it says, look at this problem below. Why is this not in simplest radical form? So 7 over 5 minus radical 2. And you can say, well, this isn't in simplest radical form because there's a radical in the denominator. Remember, we cannot have a radical in the denominator. We've seen this before when we were rationalizing our denominators, but before it was just like radical 2, not like 5 minus radical 2. How do we get rid of that? Okay, and so to rationalize this denominator, we must multiply by the conjugate. I wanted to say conjunction, and then I knew that was not right. An example of a conjugate can be found in example number 4, up top. 4 plus radical 10 is the conjugate to 4 minus radical 10, okay, and vice versa. Okay, notice what happens when you multiply the conjugates together. The radical term cancels out, or disappears, goes away. Easiest to spell, maybe. Okay, this is why we multiply this problem by the conjugate. So as we look at this problem, just going through it, we have 7 over 5 minus radical 2. To put this in simplest radical form, we'd say, hey, let's do fancy 1. Okay, but instead of saying we're going to just use radical 2 because that's its radical, because this is a binomial on the bottom, we have to choose to do fancy 1 with its conjugate, which in this case would be 5 plus radical 2. Okay, which allows us to, not 5 radical 2, 5 plus, which allows us to use the same skills that we just talked about leading up through this lesson. So up top we have 7 times 5, which is 35, and 7 times radical 2, which is 7 radical 2. Right, just distributing it up top. In the denominator, okay, we'll have to FOIL. I'm going to do that off to the side here. 5 minus radical 2, 5 plus radical 2. So I multiply this across. I already know I have 5 radical 2 and negative 5 radical 2. They cancel out. I have radical 2 times negative radical 2, which gives me negative radical 4 or just negative 2. So 25 minus 2 gives me 23. And so then our final answer is 35 plus 7 radical 2 over 23. Okay. Take a second and try the last problem. Tell me what you get. Okay, so let's go through that really quick. It should look like this. You should have chosen 7 minus 2 radical 3 as the conjugate. Okay, and so up top you got, what is that, 91 minus 26 radical 3. And in the denominator, choose your conjugate, right? That's 49, and that's 4 times 3, which is 12, 37. Okay, and so because here you would have gotten 14 radical 3 and negative 14 radical 3, which would have canceled out. Okay. All right, so there we go. That is operations with radicals, which focus mainly on FOILing, multiplying, dividing. Obviously, we did addition and subtraction as we simplified our radical expressions. All right, see you. All right, see you.